trees, and also in the shadow area this is a bit better. In the previous one we had more gap here, and here is less. And also you see that the points are more denser, and here is the piece for the Mapper Pro, and this is a bit more comparable to Agisoft and better than 3D survey. And this is the shore, and this is the shore as we saw that the number of points are much higher than the 3D survey, but a bit less than the P4D and Agisoft. And then we continue the qualitative assessment using comparing some local profile that we generated over some specific object. Here we have a building, for example, roof. We provided some profile along this red line. So and then we generated the profile. See that the blue 3D survey, the red P4D, black shore, and green Agisoft. And finally we divided the error into the 4 type. E1 is smoothing effect, E2 vertical shift, E3 horizontal shift, E4 elevation spike. We see that, for example, here that this is the green one, which belongs to Agisoft, has always a bit bias, a bit shift comparing to the other one. And but horizontally they are. I mean, this Agisoft, the Pix4D, and Shore are more, close to each other horizontally, but 3D survey is a bit larger. And we see that some spike here, E4. This is a spike here. This means that there are always some noises, above ground noises, exist in 3D survey. And here, this is over a flat surface. This is along the surface. We see that there are some more spikes on Agisoft even. We have again see that there is a bias, there is a shift between the Agisoft and the rest, and also see some bias in the other side for 3D survey. But the shore and Pix4D are very close to each other. Another area in the vegetation area, the comparison is a bit hard, but just a little we could see that still the Agisoft is higher than the others. In the hilly area, we will see again those effects. You see that again Agisoft is higher, the 3D survey is a bit lower, and Pix4D and Shore are more close to each other. And we see that some smoothing effect that you see that here in Agisoft, and also here in 3D survey. We see that the area is more smooth comparing to the Pix4D and Shore that shows more small structure, more roughness in the area. That means that this finding the conjugation point is much stronger, and even in almost unstructured area. So the result and discussion regarding to the qualitative assessment, we generated the profile and DSM along different land cover type. In 3D survey there are smoothing and detail removing effects, especially in natural topographic objects such as tail, as we've seen. We have large vertical and horizontal shift and significant elevation spike, again in 3D survey. In Pix4D, on the other hand, and Shore, which are more close to each other, the results are more appealing, and trend of elevation profile are more similar to each other. The smoothing level in a Shore has been shown that this is a little more than Pix4D Pro, and result and it causes small elevation difference. Okay. In Agisoft, there are significant vertical shifts. This is always, and elevation spikes at the flat surfaces. However, the small elevation differences are smaller in the Agisoft comparing to the Pix4D. And also regarding to the vegetation area, it is accepted to have many small height differences. So because of the behavior of the tree, therefore for software, sure, more or less the same quality, or let's say you cannot really compare them, other than that small shift that we have always seen on the AgiSoft result. Regarding to the quantitative evaluation, so we see that the average mean error and standard deviation between Shore and Pixford is very, very much less. Therefore, they are very, very close to each other. On the other hand, the maximum deviation is between 3D survey and AgiSoft. And we saw that the AgiSoft is almost higher than the others, and 3D survey is lower than the other. Therefore, the deviation is much higher. Regarding to the previous one was regarding to the point cloud. I mean, we compared the point cloud, but now this is regarding to the DSM that has been generated in 2 centimeter grid using IDW algorithm. Again, we see that so the significant elevation bias of approximately 20 centimeter in AgiSoft DSM, that we see that. We said all AgiSoft, we see that comparing to the other 20 almost centimeter different. The average of median error between AgiSoft PhotoScan is compared to the other software is again 25 centimeter. And no systematic error bias between Pix4D Mapper. You see here, Pix4D Mapper and Shore. DSM and the mean and the median error of height difference is close to 0. And again, another evaluation which again proved what we have discussed in previous results. Again, Shore and Pix4D are very much close to each other regarding to the RMS and the standard deviation that had been measured from DSM. And our systematic bias between Pix4D Mapper and Shore, and the highest value of RMSD and standard deviation are for height difference between AgiSoft and 3D survey, as we have shown beforehand, 40 centimeter. And quantitative assessment, again using a bit more robust parameter, which is called normalized median absolute difference. This is again proof that the lowest value of NMAD is 1 centimeter for the height difference between Pix4D and Shore, and the highest value is for the height difference between 3D survey and the other 3 software. And 3D models from Pix4D, Shore, and AgiSoft are much similar to each other, but are very much different from the 3D survey result. And this is another comparison between the quantile. We see in the left hand that the quantile 68.3% has been generated. In the right hand we see the quantile 95% has been generated. If we compare, so the error value in the 68%, 95% quantile between 3D survey, yeah, this one, these 2 red boxes, and the other 3 software indicate that about 27% of the generated points by the 3D survey lead to high elevation differences. That means you see that the difference between 68 and 95 is 27%. These are at the end of the curve, and that means and you see that it has much effect on the difference. That here is 0.68 and 0.16. That means this much differences coming from those area in the 27%, the last part of the curve. This is another one, QQ plot. QQ plots indicate that when this part of the plot, as long as it is close to the horizontal orientation, it means that the compared to DSM are very close to each other. You see here that the blue is corresponding to Agisoft and Pix4D. That means Agisoft and Pix4D are very much close to each other. And the red is 3D survey and Agisoft, which is at the end. That means have more inclination. Therefore, this is much deviated from each other. And so finally, we have also added some other parameter, and we give them some score. You know, we have for software, they are trial license validation, 15 days, 30, 7, and 14. And whether they are good, you know, so we give them a good score, for a very good score for 2, and score 1 for good performance. We did this score for good documentation and report exporting. I mean, Agisoft and Pix4D is very good. For parameter controlling, flexibility of giving the parameter, again, Agisoft and Pix4D are much flexible comparing the other two, being user-friendly and variety in output production and independency, and also time and memory optimization. And finally, this is the final sort according to those parameters. The Pix4D is much more flexible and much more friendlier, you know, all these parameters that have been mentioned here. So this is the final conclusion. The study demonstrates the capability of commercial photogrammetric software packages for automatic 3D reconstruction of different features using high-resolution aerial images over a historical site. Various visual and geometric metrics are used to measure the quality. I mean, we had visual and we have geometric, and also we had comparing to both the vector and point cloud and also DSM data. Despite